Okay, my name is Nigel Pinnell. This is my circuit building project. I should rearrange this a little bit. Okay, so basically to introduce the project, we're just going to be sending a bunch of signal through a bunch of these different wires, resistors, and conductors and a bunch of things like that, and sending it through speakers and looking at our ohms and things like that. So to start off, I've obviously hooked these two ends up, so we have our raw signal. And pretty self-explanatory. So now I'm going to add a resistor. Here are my two resistors I'm using for this project. Here's this one. This one is brown, black, brown, and gold. So brown is 1, black is 0, brown is times 10 to the first, and gold is plus or minus 5. So that'd be 10 times 1. Okay, so 100. So okay, that actually works out pretty well. So 100. Get another cable to hook this up in here. And make sure I have the right yellow end here. Okay, so with the 100 ohm resistor, you can obviously tell that the signal is a lot quieter. Our total resistance for this, obviously it's 100 plus the 8 out of the speaker. So obviously our total resistance would then be 108. So now I'm going to go ahead and add that our other resistor here. Here's this one. Brown. Oh wow, it's the same one. Brown, black, brown, and gold. So these are both 100 ohm resistors. That works out really well. Put this in here. Get our other green cable. And now these are these are in series. Let's see if we can. Oh, there it is. Okay, you can obviously tell the signal's a little quieter. It's not a whole lot different, but it definitely is quieter. So then obviously, if we're just adding 100 ohms of resistance to our original series, which was 108, our total resistance here would then be 208. So now I'm going to go ahead and put these, and obviously the signal's gotten a little bit quieter. It's not a whole lot of difference, but there's some of the bottom EQs are kind of gone. I'm pretty sure that's just because the level's quieter. So now I'm going to go ahead and put these in parallel. Here's our one resistor. So we're going to go ahead and send a line off of this guy to this guy. Bring it back to the resistor. And then where's another? So I'll use another yellow one. And then send the signal back from our original resistor to our raw source, and hopefully we get some sound. Ah. Okay. Well, I mean, the signal's a little louder than it was in series now that it's in parallel. So I'm gonna unplug this just so I can think for a second. Okay, so obviously if we're adding up resistance in a parallel circuit, so we have to take the reciprocal. So we have 100 ohm resistor plus obviously another 100 ohm resistor plus and I'm doing the reciprocal, so it's the reciprocal 1 over 100 plus 1 over 100, and then we have our 8 ohms from our speaker, so it's going to be 1 over 8 equals the reciprocal of x. So common denominator of 108. Well, 8 goes into 200, well, no, 25. So, okay, so 200 would work. So, let's see here. So that would turn that into 2 over 100. Or, I'm sorry, 2 over 200 plus 2 over 200. Plus, then it'd be 25, because 20, yeah. So 25 over 8. Or, I'm sorry, over 200. That was stupid. And then 25 plus 2 equals 29 over 200. And then obviously we want the reciprocal of that. So if we do 200 divided by our 29, we get 6.89. So let's see, I guess that would be right, because if you're doing, okay, alright, well that makes sense. Okay, so then now we want to do, I'm sorry, I'm trying to look at this. So then the resistance of the circuit would then be 68.9, which makes sense because that's less than 100, which is so obviously everything works. And I mean, this as far as how the signal was affected, it was. I mean, if you listen to it again. Oop, just get this thing clipped on here. Okay, I'm pretty sure it's a little quieter, but we'll compare that to our raw signal. Oh yeah, it's definitely original signal is definitely a lot louder. So okay, so now now we're done with these resistors, so I can get rid of these, or go ahead and unplug these so I can use these cables later. Get this over here. Okay, so now I'm going to be using one of these guys. And obviously I need to hook up, I need to hook this up to the middle one. Get some sound here. Hopefully when I plug this in here, okay, so that does work. Okay, so there's full volume. Oh, it's a little touchy. And as I turn the wheel, well, it's being a little touchy, but you can hear that it's fading in and out. Oh, that's all the way. And then you can hear it gradually getting quieter. Oh, okay, all right, that's enough of that. Okay, well that takes care of our resistor, so put that back over there. Okay, so now we're gonna start working with these conductors. So obviously I'll show you again. Here's our original signal. Signal. Oop. Why aren't we playing? This thing is very touchy. I wonder if the track. Oh. Come on, I know you're there. Try flipping this around. There we go. Okay, so that's our raw signal. So now we're going to add one of these conductors, which is 10. It's an M word, and I'm now drawing a blank on the name. Oh, it says it right here. Microfarads. I'm pretty sure. I'm sorry. Pardon my pronunciation. We're going to then add this to our little chain here and see how it affects the sound. Okay, well, as you can tell, I mean, it's cut out a lot of the mids. I mean, there's still a little bit of the mids. There's absolutely zero low end at all. So this, obviously it's literally just pushing a bunch of high end. It's not really much else. Okay, so then we're going to add a second conductor. Here is our second conductor. Go ahead and add this one to our chain here. Clip that guy on there. This other clip. Hopefully we get some sound. Yeah, now it's even more just pushing straight high end. It's not, no, you almost can't even hear the kick at all. There's literally no thump from it at all. It's just the sound of the head hitting the drum. There's no low ends, and there's basically no mids either. Okay, so these are in series. So the total impedance in the circuit, obviously we're just, this is where we have to, this is when we use the, this is the opposite because these are capacitors. So in a series, we want to add it up. That's when we use the, whatchamacallit, that's when we use the, why can't I think of that word? Reciprocal, thank you. So let's see, well, they're each 10, so 1 over 10 plus 1 over 10 equals the reciprocal of x. So obviously that just turns into 2 20ths equals 1 over x. Oh, I mean that turns into x, and then we need the reciprocal of that answer. So then obviously, all right, well, I don't know why I said 2 20ths. It's 2 tenths, and then obviously 10 divided by 2 is 5. So then your answer becomes 5, which is then your total. So then if I do these in parallel, let's get our original one here. Add an extra leg onto this side. Bring it back to our original guy here. Add an extra leg. Bring it back to our source. Okay, well, as you can tell, it's canceling a lot of it out because we have, compared to our original signal, there's a lot more mids, and there's even a little bit of low end, and we'll listen to it again. I mean, you can definitely hear the difference. So then our total for this, and then it's in parallel, so then we're literally just adding it up. So then we just get 10 plus 10 is 20. So then our answer is simply 20. There's no other real math involved in that. So now we're going to start testing these coil strips here. There's three coil strips. Here, let me break this apart a little bit so we can make this a little more simpler to look at. Get rid of our capacitors and whatnot. Okay. Oop. Where's the other one? Here it is. Okay, so here are 3 coils. So obviously, the audio that has been the most affected, the coil that has the most effect over the audio is going to be the one that has the highest impedance. So let's just try and see if we can get these ones to go.